Okay, so in my last video on the RPM notch filters, we kind of talked about the fundamentals of what it is and what it's doing, but I didn't really go into data on the performance and what we're seeing in testing and so on and so forth. So we're looking at real data here on the performance we're getting out of the new RPM notch filters. So to do this, what I did is a test flight of the Betaflight 4.0 with the RPM notch filters turned off. Basically, it was the stock, just the defaults. The only thing I really changed in there is I set the dynamic notch Q to 200 because that's what I wanted to do my test flights on with the RPM notch filters turned on. The default is 120, so 200 Q on your dynamic notch makes it narrower, so it doesn't hit noise as much, but it reduces the phase delay. Like increases, I guess, performance, but doesn't capture as much noise because it's a little narrower, like I just said. So you can see in here, and the dynamic notch was improved a ton over Betaflight 3.5, just in how the tracking. I have tons of data on that if anybody wants to see it. Okay, with this you can see we have the motor band, and we talked about that in the last video, which I'll make a link in the upper right. And in that motor band, you can see the dynamic notch is tracking that and crushing that out. Wherever that peak is, it's kind of tracking that as it goes up in frequency as you increase your throttle percentage. So higher throttle percentage, obviously the motors are spinning faster, so the vibrations coming off of the motors increases from around 200 hertz, 200 times per second, the oscillations going up and down, to around 400 or 500 times per second as the oscillations and the vibrations are going up and down. You can see that band is there. It's getting killed out, much better than just a low-pass filter, because a low-pass filter really just helps with this broad dispersed noise. You can kind of see here on the D term, because the D term magnifies it. But you don't see that peak band. And what I mean by that is, when you pass normal motor noise through just low-pass filters, this is what you'll get. You'll see that it will hit, the low-pass filters will hit the dispersed noise, like this blob up here, but it won't hit that band. So this is kind of the helio filter, which is some low passes in cascade, and you can see that motor band just still breaking right through, where this is Betaflight filtering with the RPM. Now this is the RPM notch filter, so you can see that motor band is just crushed. Notch filters were designed for that specific purpose in the audio industry a really long time ago, and that's why we're using them for peak noise here. Okay, so back to Betaflight with the RPM notch filters off, Q200. You can see it's a little bit there, and then let's look at now with the RPM notch filters turned on, and then I also adjusted, because now you have more filtering, so you can't just turn them on, and you can't have them off and then just turn them on and say, oh look how much better. It's like, no, of course it's better. You have more filtering. You have to dial back. You also have more phase delay. If you don't know what phase delay is, I'll make a link in the upper right to my filter fundamentals video, and you can check that out as well, and talk about what phase delay is there and some of the basic terms we're using here. Anyways, to make up the difference in filtering, what we did is, and the goal here is to turn off more low-pass filters. Low-pass filters inherently have more phase delay than notch filters down low in our control frequency band, from like 0 to about 80 hertz. Low-pass filters, the phase delay goes up as you go from the cutoffs, which are around like 100, 200 hertz, and you go to lower frequencies, the phase delay gets more and more and more and more and more. Whereas notch filters, it goes the other way. As you get to the lower frequencies, it goes down as you get into our control frequency band. It doesn't go up. So that's, you kind of look at these fundamentals and you say, oh, okay, which direction should we be going? And that's why Betaflight's going this direction with all these notches. So to make up that difference, it's changing the gyro low pass 1 from a biquad, which is the default, which was the last plasma tree you saw. It had the gyro low pass filter as the default, which it had biquad. And it changed that to a PT1, which halved the amount of phase delay from that low pass. It also halved the amount of attenuation as well. So that made the gap. So you can see between this image and the last image, they have the same phase delay. So the same amount of delay, and now it's really just comparing the graphs, because now it's the true apples to apples. Which could kill noise better with the same amount of phase delay. So if you look at these graphs, you can kind of see it here, and we're really looking right here. And obviously you can see why the RPM notch filter is an advantage. It's killing out that peak. It's killing it out here, here. If you look on the far right, you can see there's a peak breaking through here, but not so much here. And then the D term amplifies noise, so you can see the differences there on the D term as well. Okay, so that was plasma tree graphs. Let's look at the motor traces. So this is a motor traces from the same logs, and you can just see here this is without the RPM notch filters, and this is with the RPM notch filters turned on, but the low pass one adjusted, and you can see how there's basically less vibration going to the motor traces. So what's that going to help you with? It's going to let you get higher RPM sounds out of your motor. Basically, your motors, when you go to full throttle, you're going to hear a higher amount of RPM. Some you might be a lot. Some, if your quad is really clean, it might just be a little. It's obviously going to vary, but it helps a little bit there. Also, battery life helps a fraction. Again, it's going to vary based on how noisy your quad is, motor, so on and so forth. The big point is that killing out that motor band is pretty critical. So now that we have this motor band kind of crushed out, and you can even see it's crushed specifically more in the motor band more than the ambient noise around it. So it's almost like we went for this peak of noise at the motor band to now there's kind of a deficit, and the ambient noise around it is still there. And that peak motor noise, that's what would really excite the D term. So we can really push the D term higher. We can turn filtering off even more to be a little bit more aggressive. Now that we have this flat line base here of noise, you can turn off the low pass filtering, and I don't know about turn it off, but you can make it more aggressive that this raises up consistently with itself. So the ambient noise level goes up a little bit, but you don't have these peaks that are kind of problematic for you for the D term. Some other information we can now get from the RPM or the real-time RPM data as well. So we can see how, based on motor input, so these are the motor commands from a real flight, from those logs, that are going to a specific motor. So this is just one motor. I think it was motor 1. And wanted to see, okay, well, we're given it these sharp commands, full throttle, half throttle, go back up, and, slow down, so on and so forth. And what is the actual, how fast is the motor updating? The real-time RPM data is at 1 millisecond frame rate. So it's 1,000 hertz. At least that. It could be faster than that, but I know in the logs it's at 1 millisecond. Well, interestingly enough, and Preston Garrison would say this for a while, the motors really act as low-pass filters, and they totally do. So you can see in here that the motor command obviously is the orange, the RPM data from the motors, and there's some jitter in there just from the signal coming back out. That gets smoothed out in the notch filtering before it goes out to tell it which megahertz or hertz to be at for the filters. There's a smoothing element on that, but this is unsmooth, so it's just the raw data, and there's a little bit of jitter there, like I said. And you can see the delta between the two. Then this red dash line, which I offset up a little bit just so you could see it, is the motor commands put through a low pass filter, or first order low pass filter, which is what the PT1 filter is in beta flight, or the frequency filter in flight 1, at 5 hertz. 5 hertz. So that's really low cutoff. So we can easily calculate a first order low pass filter, the PT1 or whatever, at 5 hertz. This is what it looks like in noise attenuation. Here's what it looks like in phase delay. Look at the phase delay, up to 2 milliseconds. So for command frequencies, 0 to 20 hertz, this is just bank left, bank right. As it gets to be a faster command, it's 10 milliseconds. So in prop wash band, I have it all the way up to 90 hertz, but I have never really seen prop wash above 70. So I'm kind of being generous here for the naysayers. But you're talking about 8 to 3 milliseconds in delay. And you can see that mapped over top of it. That's what we're getting. So what's the difference here? The difference is our commands are a lot more aggressive than the motors can dream to keep up with. So my takeaway here is the best thing for prop wash handling is you have to have high-powered motors and lake tip props. That's key first. I made a post on this on March 1st on my thoughts where people need to really focus their attention really when it comes to prop wash handling and stick feel. I know I'm big on filters, and they are important. You know, trimming off as much phase delay as we can because it offsets the entire gyro signal back, and it does make a difference in prop wash, gaining that couple milliseconds of time and reducing that latency. However, it is definitely not the biggest factor, I would even say, for prop wash, and secondarily, it is way not the biggest factor for stick feel. So I check out that post for how I kind of construct what I'm saying are the main factors for stick feel. Primarily, it's honestly some of the OpenTX stuff and how FR Sky transmits things, how the RC signals are getting smooth, your mechanical setup. Obviously, it's got to be the same exact quad to compare things with. You can't use two different quads. It's just ridiculous. And some other things. You know, filtering's in there, but you know, it just doesn't add up. These other things have double digits. You saw on the prop stuff, that's 30 milliseconds, 20, 10, double-digit millisecond delays on this stuff. Same thing with RC filtering, the commands from OpenTX, your stick feel. You should even get into the camera latency as well. Those are all double-digit latency numbers, and then filtering, we're down to like 3 or 4 milliseconds compared to like 10, 20, 30. So yeah, I just want everybody to take a look at that post. Just make sure you're focusing on the right spot. If it's a stick feel thing you're really looking at, I would get off the filtering. Filtering is for more prop wash than anything, and you know, filtering can only get you so far if you have really heavy props or really weak motors. You know, it's not gonna. You just can't get everywhere with filtering. There's these other more important factors. So check that out. Drop any questions you have down below. And I'll depart with this. So this is a full flight with the RPM filters. This is kind of what I'm getting on my rig for, you know, kind of I've played around with a lot of things. It's basically the defaults. What I would recommend at this time is limiting the harmonics, the amount of harmonics on your RPM notch filters. You don't know what I'm talking about, go check out the video on the RPM notch filters. Limiting those to 1, so you're just getting 4 RPM notches on each axis, not 12 as the default. I think 12 is just, I mean, if you have the first and second harmonic, sure, but I don't. And if you have those harmonics, it's like you should really switch frames or something. But nevertheless, limiting that, changing your gyro low pass filter, it being dynamic, getting that set correctly, and changing that from biquad to PT1. And that's what this is. And then starting to take the Q factor up on your dynamic notch to 200 or even higher. Another thing you could look at doing is making it a single dynamic notch versus dual dynamic notch. So we'll get into that a little bit more. Betaflight 4.0 is under release candidate right now. Good stuff. But you should be looking for graphs kind of like this. And you can see in here, you know, where the RPM motor band is, it's darker blue than everything around it. So the RPM notches are really hitting that really nice. And that's why there's excitement around it, because it was showing such a great thing, performance to hit those. I'm fully aware that Joshua Bardwell just did a video on this, and I don't think he was that impressed. He was gracious enough to upload his logs onto a group, and this is what his logs look like from that flight. So something wasn't right. It looks like the RPM notch filters were on. I believe he turned off the gyro low pass altogether, and then the D-term low pass altogether. That's a little aggressive. I wouldn't do that. You can't turn off the D-term low pass, and you can see there's his pitch axis is a mess. So that's what he was getting on that. I really think you should take a second look at that. A lot of the stuff from my seat, how do I say this without? So the scientific method, the way it's based is you're not interested in people's opinion, right? The scientist doesn't go to another scientist and says, "Oh, what's your opinion about the nuclear fission?" Blah 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 blah. They say, "Show me the data, show me the evidence. Let's stick with that." Opinion. You can draw conclusions from data, but opinions don't matter. Conclusions, but those conclusions need to be based on data. So, with that, I think the data coming in was not the greatest, so the conclusions would probably be different. And I would hope that everybody can work to get the data they're basing their conclusions on good before they render a conclusion. I think hopefully that sounds fair. And I know I show you these plasma-tree graphs, and not everybody might not know what they look like, but this was my log, put the RPM notch filter at 100%. This was Bardwell's log at the notch filter near 100%. You can see the motor noise was so drastic that at some point, even with the throttle near 100%, well, it wasn't 100% right here, which is even worse. It was dropping some of the motor commands all the way down to 0 or 2. So, yeah, there was a lot of noise there. Not good. Luckily, it was, I think, cold outside, so he didn't burn up a motor or his motors or deal with heat very well. Oh, and jumping back to this real quick, just because I touched on motor heat. This differential right here, see that difference from here to here? That's what goes into heat. Your ESC is commanding this to the motor. So the magnets are powering up to do this, because that happens quick. Except the bell can't physically start to rotate faster. Well, fundamentals of energy means that if that energy is not being transferred into motion, where's it getting transferred to? Heat. It's got to go somewhere. So that is the heat being generated. So there's heat generated here, here, here. Basically everything in the commands that the motor is not able to hit, obviously small little ones, there's not much heat at all generated, right? Big ones generate more heat. So that's what generates hot motors. Your ESCs are commanding things your motors can't keep up with. And this is with a well-filtered quad. If you have a poorly filtered quad, then these vibrations are up and down a heck of a lot more, like all throughout here. These would be up and down, up and down, up and down, up and down. And this would have more instances of a gap between where the motor can't respond to and the ESC signal command. So that generates even more heat. Okay, well that is it. Hopefully you gleaned some value from me jabbering on around this stuff and showing you some data points on at least what the Betaflight devs are seeing and some of the tests I've done on it. I'm happy to make this data available to anybody interested in the data, what you're seeing back in experiences and also information and data. Everything I'm seeing is that things are going in the right direction, which is a good sign. We're getting better filtering for less phase delay, which is where we want to get going. I have heard out there people are saying, we're probably getting to a point of diminishing returns. I'm kind of with you on that. We're getting really low phase delays at this point. We're down sub 4. We're in the 3 milliseconds. If we get that to 2, that would be great. I know a buddy of mine just was running some RPM notch filters just tonight on 1K mode, and his with no low pass filters on the gyro, and his result was looking like this, really clean. So that's exciting. We'll see where that goes, because it's the lower the sampling rate, the less high frequency noise you pick up to begin with. So it's just don't look. Basically, if you don't look, then you don't see it, and then you don't have to filter it out. So we'll see where that goes, but there's some alias and things we got to talk about, things like that, and look at and vet some more. More exciting information to come. Found a bunch of interesting stuff with FR Sky, and coordinating with FR Sky to see if we can make that latency better. I know Joe Lucid found a bunch of interesting stuff with OpenTX. There's something you can turn off in your transmitter to make the latency drop down quite a bit, because there's a filter in your transmitter. Make a video on that soon, post that up, let that get vetted. That's like just yesterday or the day before. So I think there's a lot of exciting things that people are exploring and getting some great results for, and then those are directly tied to better stick feel, better flight experience, that kind of stuff. Thanks everybody, I hope this helped.
ideas.